Hi, my name is Ross, and in this video I'd like to go over my best tips for reducing fractions with 6 relevant examples. Stick around towards the end of the video and we'll go over a bonus tip and a bonus example as well. So here are my list of tips for this video. 1. Don't cry, flip and multiply. Whenever you see division of fractions, there's an easier way to go about it. 2. Reduce early or reduce first. So try to divide things first or simplify first and then multiply what's left over. This allows you to avoid, having to work with really large numbers, especially when you have a long chain of multiplication of fractions. 3. The order of multiplication and division doesn't matter in this context. So of course, the divisor number, the number being, the number of pieces matter, but the order in which you do your multiplication and division doesn't matter, and that's based on the commutative property of multiplication as well as order of operations. So make sure you don't change your problem by rewriting it in an incorrect form, but note that you can order your multiplication or your division to suit your needs and your tastes. 4. The fundamentals don't change even if the scale of the question does. If you're multiplying 6 fractions together, every single thing you do is a combination of the basics. And so the goal is to have a very logical strategy for how to work with any number of fractions or any scale of problem. So that's it for my regular tips. Let's just go ahead and tease the bonus now. Tip number 5 is create realistic expectations. Not every answer will be simple. Your answers could be 8, they could be 2, or they could be like 1/millionth, or they could be 3/37ths. Whatever sort of problem you're working with, the answer will be a number. Whether it's a fraction, you're asked to provide a mixed number or a decimal, it doesn't matter. Just stick to the basics, stick to the concepts, and we'll get through it. So now that we have our 5 tips, let's go ahead and focus on them one at a time. But we're going to switch over to these examples so we really grasp how tangible and concrete all these tips are. So let's go. All right, so here we have 4/3 divided by 2. So the tip here is don't cry, flip and multiply. So whenever you're dividing by fractions, you always are able to rewrite that in terms of multiplication. So here what we do is we write the first fraction and then we multiply it by the reciprocal. So a whole number reciprocal is just 1 over that number. So flipping is reciprocating. And then you go ahead, in my book, you always simplify first. So I'll just write an extra step here. And I'll sort of, cheat, if you will, and then I'm doing 2 things at once. So the 4 and the 2 divide out, and that leaves me with 2 times 1/3 or 2/3. So the idea here is just, regardless of how many you have or how complicated it is, if you're dividing 2 fractions or even more, you do it one at a time, you flip and you multiply, and then you go ahead and you use all the other tips. So let's go ahead and move on to the next example. So here we have 8 divided by 8/3. So okay, we're going to use our first tip. We're going to flip and multiply. So get the reciprocal of the second or the bottom fraction. Another mini tip is to, write your fractions as a number divided by the other, like over, top and bottom. That might help you see this right away. It's up to you. So that's a little extra right there. And like we noticed before, you can always reduce early. So I would say, well, 8, for every 1/8, there's another one. So that is 1 times 3, or just 3. Notice how I'm not canceling, like I'm not deleting. There's no zeros or subtraction. And that's just a matter of semantics, if you will. But I think it's really clear to have a good, stable, very clear language to discuss this. And so, we could have said, well, that's 24 over 8, and then that's 3. But notice how, in this case, 24 is not a big number, but you can imagine that as the numbers involved get bigger and bigger, you really don't want to do that multiplication first. You want to reduce early or reduce first. So let's go ahead and keep moving along with that vein. Let's reduce early. And actually here, this works too. I was thinking about doing a different problem, but so here we have, okay, our first step, flip and multiply. Okay, you can cry if you want to, but it's okay. Okay, so for every 4 in 8, there's 2. So here we get a 3/2. And that could be the end right there. If you're just asked to, what's the simplified fraction? This is also 1.5 or 1.5, depending on if you need to think about mixed fractions or decimals. That's just a little tidbit there. Okay, so let's move on. All right, so here, no division, no need to flip and multiply, but we still need to reduce and think about our order of operations. So let's go ahead and focus on order of operations. So right here, as you can see, the 8 is first. So let's go ahead and just multiply across, right, numerators and denominators. But here I want us to focus on flipping the order. So let's go ahead and swap the order for the 6 and the 8. So 8 times 6 is 6 times 8. And here you might more readily see the reduction. So there's 2 3s in 6. So those reduce or divide. And there's 2 8s in 16. And so let's go ahead and do this one step at a time. We could have said, oh, well, 2 goes into 2 one time, right? So the answer is 1. Now, you might have seen that at the beginning. Another order is I could have reduced the 6 and the 16 because they both have a 2 in them. So just a little pro tip, this could have been written as 8/3 times 3/8. And then we would have really seen that it was 1 right away. So that's what I mean by order of operations. It's all multiplication division. They all have the same priority. So it doesn't matter, but you have to make sure that when you're rewriting stuff, you're not rewriting the problem, you're just choosing a different order for the multiplication and the division. Okay, so I know we're going a little fast. Let's just slow down a little bit on this one. Here, okay, we still need to flip and multiply, and then we get to choose that order of operations and reduce early. As you can see, the numbers are getting a little bigger here. So, okay, we have 5/48. Remember, the first fraction always stays the same. You flip or reciprocate the second fraction. Okay, and I don't have to rewrite it, but I can still do my order of operations. So let's just do one thing at a time. Let's go ahead and change colors while we're at it. So 1, 5, there's 3 and 15, or 5 divides into 15, gives you a 3. Okay, let's go ahead and give ourselves some more room here. So now we have 36/48 times 3. And notice how, I'm not multiplying that 48 and that 3. Okay, so let's go ahead and introduce sort of another thing we can do, and that would be factoring. So let's go ahead and break up our 36 as 12 times 3. And then 48 is 12 times 4, and then we have that times 3 still. So just to clarify, we're breaking up these numbers here. We're factoring at this step. So let's go ahead and write that, factoring. And then we're going to get back to reducing. So here, the 12 and the 12 give you 1 on both the numerator and the denominator. And then there's a 3 and a 3. So the answer, you multiply everything now that it's all simple, is 1/4. And so you can see how having an understanding of how multiplication and division work, and that fractions are just sort of they're more detailed, if you will. And then understanding that, you can have clear strategies and tips to keep the numbers simple and smaller and more manageable. Okay, so we have one more before we get to our bonus. And so here, I just want to talk about scaling the basics. So think of everything we've done up till now. Right now here, we just have a third fraction being multiplied, but none of our strategies change. We just have to do more steps, or it's just slightly more work, if you will. So we can go about this several different ways. I'm going to go ahead and reorder the multiplication first. So let's do that in green. So here I'm not gonna write it all as one fraction. Well, let's just do it. Yeah, let's be consistent. So 8 times 9 times 15, 3 times 5 times 4. And if you notice, 3 and 9, right, go together. 5 and 15 go together. 4 and 8 go together. So let's go ahead and give ourselves some more room. And let's go ahead and say 8. 8 stays the same. Let's move the 4. And then, maybe we'll do the 15 and the 5. And then the 9 and the 3. Okay. We'll go ahead and change colors again. So for every 4, there's 2 and 8, right? And then this 1, 5 divides into 15, gives you a 3. And 3 divides into 9 and gives you a 3. And then we're still multiplying. So don't forget that we're multiplying. And so we get, so everything in the denominator simplifies. 2 times 3 is 6. 6 times 3 is 18. So let's make sure we didn't do any goofs here. Yeah, I think we're good. Okay, so that's pretty much it for just working with fractions, multiplying and dividing. Let's go ahead and move on to that word problem, or the bonus problem. So I didn't actually say this, but it's going to be a word problem or a story problem. So here we have, the story problem. It says, what is the length of a rectangle of an area 15 square meters if the width of that rectangle is 3 meters? So let's go ahead and draw a picture. We have to know a few things, right? So this is bonus. So if this is beyond where you're at, that's okay. It's bonus. So let's say the width here is 3 meters and the area is 15 square meters. And so you have to know that area is given an A. So area equals length times width. And so we usually write that A equals length times width. So here this is W, and here's L, and we don't know it. Okay, so let's keep working. So if A equals length times width, then that means that the length is going to be the area divided by the width. So this might all be pretty new to you. It's okay if you're kind of struggling at this point, but let's get into the fraction side of it. So the length here is equal to 15 square meters over 3 meters. And so what I want you to think about is that the units here work the same way as the numbers. And so when you're looking at this, you can think about the order. It's a fraction, so it's 15 times meters squared over 3 times meters. And so a little note, in case you forgot, 4 equals 2 squared. So when you have 4 divided by 2, you have 2 squared over 2, and you just end up with a 2, right? So in the same vein, the same thought here, we have 15 over 3. Let's just go ahead and rewrite it. Times meter squared over meters. And so you get 5 meters. So we'd say the length equals 5 meters. So because this is kind of focused on pre-algebra, I figured I'd go over this as a bonus. So it's okay if you skip to this part and move on, or if you really got something out of that. I hope you did. So let's go ahead and summarize now. Reducing fractions are used throughout everyday life, not just science and engineering. Stick to the basics of how fractions, multiplication, and division work, and make sure you pay attention to reducing early and really reorganizing some of that multiplication and division. And then bonus tip is to be realistic. Not every answer will look simple. And as if you go back to the bonus example, you'll see, and some of the other examples, is that no matter the scale, no matter the context, if you're working with fractions, they will be what they will be. But you can have a clear strategy and stick to the basics, and it'll do the job. If you found this content useful, please give us a like, and don't forget to hit the subscribe and bell icons if you'd like to be notified when the next video comes out. We hope you join our community and leave a comment down below about which math and physics tips you'd like to see in a future video, as well as problems you're struggling with. Thank you for joining me on this episode of Problem Solving with Ross. Bye. Cars, trucks, noise.